so here's an example. There's a vector space V, which is three complex numbers, three component vectors, complex vectors. So a V is equal to V1, V2, V3, three numbers, where all the Vi, each one belongs to the complex number. So three complex numbers makes a vector space like this. So somebody comes along and gives you the following linear map. T on a vector, V1, V2, V3, gives you another vector. It's a linear map. So what is it? It's 0 times V1 plus 2V2 plus IV3 for the first component. The first component of the new vector, I put the 0 V1 just so you see that it just depends on V2 and V3. The second component is V1 minus IV2 plus 0 V3. Those are not vectors. These are components. These are numbers. So this is just a complex number. This is another complex number, as it should be. Acting on three complex numbers gives you linearly three other ones. And then the third component, I don't have space there, so I'll put it here. 3IV1 plus V2 plus 7V3. And the question is two questions. Find T star, T dagger, and write the matrix representations of T and T dagger. Write the matrices T and T dagger using the standard basis in which the three basis vectors are 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, and 0, 0, 1. These are the three basis vectors, E1, E2, and E3. You know, to write a matrix, you need the basis vectors. So that's the problem. It's a good problem in order to practice, to see that you understand how to turn an operator into a matrix and you don't get confused. Is it a row? Is it a column? How does it go? So let's do this. So first we're going to try to find the rule for T dagger. So we have the following. You see, you use the basic property. U on TV is equal to V, no, I'm sorry, T star, T dagger, U on V. So let's try to compute the left-hand side and then look at it and try to see if we can derive the right-hand side. So what is U? Is supposed to be a three-component vector. So for that, use U equals U1, U2, U3. Okay. Now, implicit in all that is that once somebody tells you, okay, you've got a three-dimensional complex vector space, what is the inner product? The inner product is complex conjugate of the first component times first component of the second, plus complex conjugate of the second times star times star. So it's just the generalization of the dot product, but you complex conjugate the first entries. So what is this? I should take the complex conjugate of the first term here, U1, times the first one. So I have 2V2 plus IV3. This is the left-hand side. Plus the complex conjugate of the second component times the second component. So U2 times V1 minus IV2 plus, well, 0 V3. This time I won't write it. Plus U3 bar times the last vector, which is 3iv1 plus v2 plus 7v3. Okay, that's the left-hand side. I think I'm going to use this blackboard here, because otherwise the numbers are going to be hard to see from one side to the other. So this information, those two little proofs, are to be deleted. And now we have this left-hand side. Now, somehow when you say, okay, now I'm going to try to figure out this right-hand side. So your head goes and looks and says, well, in the left-hand side, the u's are sort of the ones that are alone, and the v's are acted upon. Here, the v's must be alone. So what I should do is collect along v. So let's collect along v. So let's put something times v1 plus something like v2 plus something like v3, and then I will know what is the vector t star this. So let's do that. So v1, let's collect. So you get u2 bar for this v1 and 3i u3 bar. v2, we have 2 u1 bar minus I u2 plus bar plus u3 bar I think I got them right, okay. And then v3, let's collect. I u1 bar, nothing here, and v3 is 7 u3 bar. Okay, and now I must say, okay, this is the inner product of t's dagger u times v3. So actually, t dagger on u, which is u1, u2, u3, must be this vector with 3 components, for which this thing is the inner product of this vector with the vector v. So I look at this and I say, well, what was the formula for the inner product? Well, you complex conjugate the first entry of this and multiply by the first entry of that. Complex conjugate the second entry. So here I should put u2 minus 3i u3. Because the complex conjugate of that is multiplied by v1. So here I continue 2 u1 plus I u2 plus u3. And finally, minus I u1 plus 7 u3. And that's the answer for this operator. So the operator is there for you. The only thing we haven't done is the matrices. Let me do a little piece of one, and you try to compute the rest. Make sure you understand it. So suppose you do t on the basis vector e1. It's easier than what it looks. I'm going to have to write some things in order to give you a few components, but then once you get a little practice or you look what it means, it will become clear. So what is t on e1? Well, it's t on the vector 1, 0, 0. T on the vector 1, 0, 0, look at the top formula there, is equal to 0, 1, and 3i. Top formula, the v1 is 1, and all others are 0. And this is E2 plus 3i E3. So how do you read now matrix elements? You remember the formula that T on EI is supposed to be T Ki EK, sum over K. So this thing is supposed to be equal to T 1, 1, E1 plus T 2, 1, E2 plus T 3, 1, E3. You sum over the first index. T on E1 is there for that. So then I read this, and I see that T21 is equal to 1. This is equal to 3i, and this is equal to 0. So you got a piece of the matrix, and the rest I will just tell you how you see it, but you should check it. You don't have to write that much after you have a little practice with this. But the matrix T, what you've learned is that you have 0, 1, and 3i. So 0, 1, and 3i are these numbers, in fact, 0, 1, and 3i, and they go vertical. So 2 minus I and 1 is the next column. 2 minus I and 1 is the next column. And the third one would be I. Look at the V3 there. It has an I for the first entry, a 0 for the second, and a 7. So this is the matrix. How about the matrix T dagger? Same thing. Once you've done one, don't worry, don't do the other one. So this, you look for the first column is going to be a 0, no U1 here, a 2, and a minus I. Zero, a 2, and a minus I, then 1 I and 0 and minus 3I, 1 and 7. And those are it. And look how nice. The second one is, in fact, the Hermitian conjugate of the other. Transpose and complex conjugate gives it to you. So that example suggests that that, of course, is not an accident.